So we are discussing about the image interpretation. So some of the elements we have already been discussed, and some are left. So we discuss about the image tone. That means the lightness and darkness. We saw it before to understand what type of what is the real color of particular object, and from then we can understand what type of object is there. We also discuss about the texture. That means sometimes some of the images are very coarse in nature, some of them are very mottled, and maybe some are very smooth, depending on their light that is emitted from that surface. Shadow also helps to understand the combination of different objects. For example, here you can see without the shadow, we cannot understand what is the object remaining there. But shadow itself shows us the real shape of that picture, of that object, and then we can understand what is therein. Similarly, the pattern which shows differently, as we saw the loop of these photographs, we can understand this is a road network. We can saw some trailers in here, so we can think about this is a park for trailer remain in there. So shape pattern also says about the interpretation. So we discussed 4 of the elements in the last class. So the next one is association. Association means to find some objects with other object. If you think there are some object which is closely related to others one, so if you can recognize one, you can similarly say others should be in there. For example, some military photo interpretation, the association is very important. Sometimes some of their instruments or vehicles remain in camouflage. So so from the point of view, from the top point of view, it might not be clearly understandable. But if you see and can recognize some of them, then you can also understand the others, and you can say that should be in there. So in association, similarly, the shape is also important. Shape shows the objects, how it's look like. So any type of shape. For example, if you wanted to find out some water bodies in some of the locations, you can choose different types of water bodies. Some of them are ponds, some of them are sorry, lakes, and some of them are maybe rivers and streams. So how do you know each of them differently? You know, if it is a round shape and the color is blue, or sometimes it is dark in color, so you can recognize that this is a pond. Or maybe you have a very large elongated and meandering nature of some water bodies, you can say this is rivers. On the other hand, maybe similarly the rivers, as it is meandering in nature, but the stream also in the same context. But stream and rivers may have some other features that can differentiate between the two. So each of the items, if you see some shape, that can give you the understanding about some object's nature. Often specific agricultural crops also looking like the same shape, which can be found differently. The canopy coverage, or maybe the distance between one or two. So altogether, you can find out what is the real positions of each one. If you can see these photographs, you can easily understand that which one is looking like what type of things. The first photographs, maybe you cannot recognize very clearly on each of the item, but if you see very roughly, the shape itself says that it is a place where something big can remain, and maybe it can be a parked runway. If you see this one and that one, so you can understand the parkways of the aircraft. Secondly, sorry, this is an athletic field, because these are the crosses. And this is the park of the runways. You can see some aircraft remain in there. Although you are not very sure about the sizes, you are not sure about the colors and other things, but you can understand there some plane can be remain in there. Thirdly, the automobiles in a salvage yard. Here maybe you cannot understand it is automobiles or anything, but you can understand there are some years where where something can be dumped or remain for a couple of times. The last one, the color itself and the shape itself, both of them can recognize that this is something related to liquid. Maybe this is a oil tanker, maybe that is a water tank, or maybe as it said that this is a water treatment plant or something else which is like liquid in nature. So shape itself give you a on type of understanding that what it could be, but maybe not very surely it can say what type of thing is there. You can, yes, you can know the type, but you cannot understand the specific one, what it is. For example, whether it is oil, whether it is water or something else. So shape is an important element for image interpretation. Size itself describes the particular nature of the objects, because one type of objects can, if you know the sizes generally, then you can also expect the others in the same size or relatively very near to that. And in case of size, there should be two different things. One is relative size, another one is absolute measurement. Relative size means if you see, for example, as house or maybe a roadways, maybe that road is very wide in nature, which remains in the highway. So if you know the general width of any highways, then the size itself you can understand from the photographs that this size could be that. And similarly, by the side of the roads, there might be something else, and you can also understand, or you can make a relationship. If the road size is the road width could be 50 meters, then what would be the size of the other things by the side of the roads? So relative size is very important, and sometimes if you know only one features, you can understand the other features through relative sizes. Secondly, absolute measurement is also important. Why? Because sometimes we are very clearly wanted to know the exact size of particular things, and we wanted to do some calculation, some quantitative measurements, for example, lengths, volumes, or something. So each of them, if you wanted to clearly do some analyze, then we need the absolute measurement. And that is also possible because each of them we can go for some calculations through stereoscopic vision, and then we can do that. Is it clear to you how size helps to image interpretation?
Yes, sir.
So in your exam, maybe I'll ask you why size is important in image interpretation, or how the size is important in image interpretation. Then you have to tell in these two ways. The last one is site. Site means where the object is located. So you have a general idea that what type of object can be remain in where. So by the side of an industry, you can expect some buildings, some machinery, something else. By the side of a park, maybe you can expect some trees, you can expect some water bodies or some playgrounds. By the side of some ocean, you can expect some beaches, and there are some other things. So site should be very specific for a specific type of elements or major objects. So if you know where it is, then you can also say that these object could be that. If the object is not very clear, but due to this site or locations, you can say what is there remaining in. For example, sewage treatment facilities can be found in the low topographic sites because this should be very near to some water bodies that finally reach in. So that's why the low-lying areas should be the treatment facilities of sewage. Similarly, orchards may be positioned at the characteristics topographic sites where it can be remained, maybe by the hillsides or maybe some other characteristics which can help the orchards in different weather phenomena. If it is very cold in nature area, so avoid cold air. You can expect some orchard by the side of the hill because to get rid of from the coldness of that area. Otherwise, maybe water bodies or something else near large water bodies can also found some orchards, because that also helps in other weather condition. So each of the objects sometimes also very related to sites. So if you cannot understand what is it by their size, nature, and other things, then you can also just guess it what could be the objectives by a specific locations. Now the question is, should we get all the 8 elements which we discussed in here? Should we measure all the things, or we should look all the elements for identification? I think no, because if you can understand the object with 1 or 2 elements, maybe that is okay, because you have already reached in your decision. So why you should go for other type of elements? You need not to do that, because you can already recognize it, you can understand its nature, and then you need not to go further other elements to recognize it. So elements, these 8 elements, maybe you can also add many more, but these 8 elements is very important to interpret any type of object in your image. And generally speaking, these things can be easily done through the digitized format of the image. Because currently the digitization help us in many ways, and one of them are they also shows the pixels very clearly in the photograph, so that we can reach a decisions whether it could be help us to find there more details, more in details. So the more information is in there, more information means more light is in there, and you can just calculate it through different other softwares, and then you recognize the object very well. So do you have any questions related to these 8 elements, which is very much essential for image interpretation? Okay, if you do not have any questions, I should go for the next one. So the next topic is stereo vision. I said you many times that the image which we use for our cases, that means in aerial photogrammetry, to interpret or to for acquisition, this image is little bit different than others. So image is same, but when we took the image, when you take the image, then we wanted to calculate something else, so that our plan and our understanding to take each of the photograph little bit different than the normal photograph. So one of them is to take the photographs of the same places from 2 different positions. It could be different angles, it could be different different distance or anything. Why we do that? We do that because we wanted to know about a certain ratio, and from that ratio we do find some very, very important information about the distance. It could be horizontal, it could be vertical, it could be other things. And from that logic, we can found a real calculations from them. And you need not to measure it now. You need not to see all the informations from that photographs every time. Maybe you can just look at 1 or 2 information in there, and then adjusted with the longitude and latitudes. And after that, the photographs itself will be calibrated through the between the distance from the one to another, and they will reach their decisions by using different softwares. So stereo vision means to see the same same point of an image into two different images, same point but two different images, and then combine together. That is your stereo vision. And stereo visions can be easily be done through some devices which we call stereoscopes. Maybe you are familiar with pocket stereoscope. We have it in our lab, and then from that stereoscope you can see the stereo vision. That means you can see two different points in the same images. We called it mosaic. So one after another, when we combine together all the images with 50 to 60% overlap, then a stereo vision can be generated, and we can see it and analyze it and to measure the distance. We discussed the digital photo interpretation many times, but here on a couple of things are important, that how digital image interpretation can help rather than the analog one, because we know digital system give us the value of 0 and 1, or we can say from the digital interpretation we can also get the pixels very in usable format. For example, if you see this one, so in the left one you can see this is a whole area with some road networks and some other land uses. And if you wanted to know about particular features of certain one, this rectangle, black color rectangle, so how do you know that? In the analog system you do not have any format that you can make it bigger or make it lower in size. But in the digital system, if your pixels allows, then you can zoom in that one, and then you can find the second photographs, because you wanted to see each of the pixels more clearly, and then you can understand more clearly what is each of the shape of each of the lines. And if you wanted to know about something else, then you can go further zoom in, and in the right side you can see another one. But as you know, if you go more in details, then each of the pixels are fragmented, and then you cannot understand the real nature of each of them. So photo interpretation in digital format help you to let you know any particular places more in details, which was absent in the analog system. So analog system give you only the one vision of a photograph, but not zoom in and not zoom out. But now in digital formation, when you wanted to see the features, you wanted to analyze it, you wanted to measure it. For example, you wanted to measure each of the lines from here. So in the left one, it might be, sorry, in the left one, it might be little bit difficult to measure each of the lines, each of them, and cannot be separated from one another. But if you do zoom in, then you can measure it very clearly, and you can just easily say what is the distance between the 2 points. So that digital photo interpretation is somehow very much important. Another thing is the format also enables the analyst to easily manipulate the image contrast to improve the interpretability. And then you can also have the full range of photogrammetric processes that can be also implemented digitally in several other processes. For example, you can do the triangulation. Triangulation means you have something analysis in your lab, in your software, does allow some calculations, and then you wanted to know whether your calculation is right or wrong. Then the same places, if you just take the information from other sites, that means in different sources, and then combine together to see whether the changes are same or not, you can do it. But in analog system, it might be a little difficult, because once you got the images of some places, maybe it is a little bit tough again to to find out other type of information from other analog photographs. But in digital system, maybe you have using some other things, for example, Google Map or Google Earth engine. So you can see the differences which you have been already calculated in your plates, and then you can just manipulate it. Manipulate means the portion where you are working, you can just put up that surface into Google Earth engine, for example, and then you can just place it in there. But in analog system, there is nothing like this. You cannot put one to another because this is analog. This is based on some papers and some others. But in digital format, you can make two layers you can overlap it onto another, and then make your calculation whether it was okay or not. Maybe you had some information regarding some longitude and latitudes of particular features, and now you calculated that things, and then you put these surfaces over the another one, and then give the longitude and latitude to see your analysis was right or wrong. So thus digital photo interpretation can give the triangulation and then compilation of many terrain models. Digital terrain models, DTMs, or sometimes we say digital elevation model, DEM. The same thing, digital terrain model or digital elevation model, that gives us the understanding about a particular places. That means each of the point, how much it is down or up from the mean sea level. So if you have your information about the mean sea level, and then you can go to run a digital terrain model of some topographic condition which is little bit in hilly in nature, then that can give you the catchment areas to see whether it is little bit down or up, and how much and how low. And also you can do some other things, for example, feature digitization, construction of orthophotos, mosaics, and fly-throughs. So each of them you can do if your photo is in digital format, and you can do the digital interpretation. Otherwise, the things would be much more difficult. Analyst can digitize features on a screen using the substantial type of machines, and then using some other softwares to know the features very well. And then you can also manipulate it into other type of information in there, and both together you can also easily send this information to others. The last topic is to know the image scale, because image scale is much more important to know the features very clearly, because in sometimes in the map scale we do have different sets of scales, and we do not know how to calculate it. But it is much more important in case of our analysis to know whether it could be a big chunk or it is very small in nature. So in the image, how can you do that? So on a scale named representative fractions, perhaps you have already know that this is a ratio between the 2 points in different grounds. So here we can do on the image scale calculations if we know the height of the instrument by which we are taking the camera. Maybe we can calculate this. We can know this from the altitudes of the vehicles. It could be the airplanes, it could be the drone, it could be anything. So if you know the altitudes, that means where it is moving on. And then if you know the camera, inside the camera, if you know the distance between the lens and the photographic image plates where the photo will put one, so that is called focal length. If you know both of them, then the ratio will be your representative fraction. This is one way to have a measurement. So the question is like, if I give you the question like a plane is flying 300 meter 300 meter upper from the mean sea level, and the focal length of that photograph is of that camera is like for example 20 millimeter. So what would be the representative fraction? Then you can do it very easily by converting the kilometer to millimeter, and then you can just have a ratio between that two, and there would be no unit in there. Similarly, you can also calculate the image scale through, if you know the ground distance. Ground distance means in a particular area, if you know the 2-point distance, and similarly you can locate it inside the focal length. So the distance between that two also can be easily understand the representative fractions, and you can use it when inside the map. So here the A and B distance is, for example, some 2.2 inches, and then you also know the distance between that is in the ground is 11500 inches. So both of them is give you a ratio sum of 1 by 52,273, because when you make a ratio, always you should have to do the upper one should be 1, so that it can understand the what is the first unit on upper and second unit in similarly the distance in the ground. So this way the image calculation can be done very easily in our photo interpretation. And once you know that, if the logic is inside your software, then maybe you do not need any further calculation. You only gaze about the image distance between 2 points in the images, and you can get the information. So that is all of photo interpretation. If you have any question, you can ask me about this chapter or this one. Thank you.
Sir, do you have to practice the maths for tutorial exam?
I will say that. But do you have any question regarding the lecture?
Yes, sir. I have a question, sir.
Please continue.
So if we know the ground distance and altitude also, what method we can use for the representative fraction?
If you know the ground distance and
also the altitude in the first method.
Okay, so yeah, so if you know this one from here to here, so you can easily understand the distance, because the ground distance means these 2 points here to here. So you have already known about the distance of the plate, and then you also know about the this distance. So your representative fraction can be divided by altitudes and ground distance divided by altitudes. So you can easily find the scale in there. Normally what we have in the images, you can see like this. If you say like this one, normally you do find some scale in here. So 1:1 something like this. It means that if you have 1 unit in your images, then 25,000 unit in your real field. It could be kilometer, it could be millimeter, it could be centimeter. So normally it could be, for images, it could be millimeter or centimeter. So if you know this one, if you already know the ground distance, yeah, so you can easily know the other one. That means the representative fraction. What we wanted to know from the images, that how can we get the measurement of particular object in the images. So in the images, what you have some features, maybe from the distance, a couple of millimeters or centimeters, and then you have 1:25,000 or something like this in the scale. So how can you calculate? Just a quick one, very easy. Maybe your map scale is 1:25,000, okay, and features you measure in your images, that the feature, for example, a car which is maybe from your point of view, just 1.1 centimeter. So what would be the real answer? That means the real length of the car. So you can just do it through 1 by 2005 to 1 by 25,000, and then you can put the 1.1 centimeter somewhere, and you change the you will find the other one. That means the ground distance. Is it clear to you?
Yes, sir. Thank you, sir.
Okay. So any other question? No. So as I said before, we have completed the photo interpretation and photo image acquisition and image interpretation. So you have to give a tutorial exam. So are you free on Sunday? Siam?
Yes, sir.
So do you have any
So we
exam
have a
on
class of
Sunday?
Ryan sir from 10 a.m. sir on Sunday, sir.
Okay, but no exam, yeah?
No, sir, no exam, sir.
Okay, so I will take an exam from after the class. So when it will be finished, Ryan sir, class?
Sir, I think 11:30.
Okay. Okay, so I'll take a class from sorry, I will take the exam from 11:30.
Sir, sir, some of our friends are sick, sir, and they are staying in their home in outside Chittagong, sir.
Okay,
Sir.
okay. So
Sir, sometimes Ryan sir's class doesn't finish until 1 p.m. Sir, so we actually don't know when it will
be finished.
start
Okay.
and it will finish. So if you want to take exam, maybe it will be better if you take before
Earlier.
his class.
So he will start from 10 o'clock, yeah, or 10:30. Siam?
Yes, sir. He start from usually 10:30, sir. 10:20, 10:30, like this.
10:30. So I will take the exam 9:30. Is it okay?
Okay, sir.
Okay. So another thing is, how many students are sick now? Do you know from your classmates?
Yes, sir.
How
Sir
many?
Nadia, sir Shubra is sick, sir, and Noreen is sick.
Okay. So these three students are present in my class now.
Yes, sir.
Okay, so can you join on Sunday, or are you still sick?
Sir, I am still sick.
Join, sir.
Okay. And other two?
Sir, I am still
Join.
sick.
Sorry. Who?
Sir, I am Nadia. I am still sick.
Okay. Okay. Fine. And Shubra, you are also sick, yeah?
Yes, sir. I'm sick, but I can join on Sunday, sir.
Okay. And then another one? Another one?
Assalamu alaikum. I can also join, sir.
Okay. So only Nadia. Okay. So I think.
Sir, Mursalin Sadnan, sir, he is in Dhaka. I heard he is for health purpose, sir. Sir, doctor দেখাতে গিয়েছে স্যার, ও তো অ্যাটেন্ড করেনি ক্লাস, ওটা বলতে পারছি না স্যার।
কাকে ডাক্তার দেখাতে গেছে?
স্যার উনি যে স্যার ওই যে বুকের প্রবলেম।
Muslim Sadlan has some health complications, sir. Sir, he went Dhaka last night. So, sir, I think he will come back after, sir, 4 or 5 days, sir.
Oh.
He has a problem in his heart, sir.
So did you also attend any other exam during last couple of days, like during last 1 week? Did you also give any exam, any tutorial?
Sir, before 1 week, sir, we've attended Diane sir's tutorial, sir. Before 1 week, sir.
So he completed, yeah?
Sir, he have completed, sir, ENV 221, and sir, we have started ENV 226 from today, sir.
So so what is your suggestion? Should I still wait for others, or I should go carry on? Because
You can wait for others, sir.
okay. So normally what happened, if you give exam after just the class, then you can get good marks, because you know everything and you can just a little bit of preparation, it could be fine. But if you take your time, then surely you will forget everything, and then you will not get good marks.
Sir, due to the situation, I think a lot of us left, and I think, sir, 4 or 5 days of prior notice would be helpful for us to all of us to join the exam.
Okay. Okay, so I'll not take the exam until 11. Okay. So this is 3rd of February. Maybe the next week I will not take an exam, and then after next week I will take exam. Is it okay for you?
Yes, sir.
Okay, done. So thank you joining me, and hopefully we will come back again in the maybe next week, or I'll say it because in the next week I'll be in travel. Maybe I'll go somewhere to attend something. Hopefully I can take a class on Sunday. Maybe let's see. I'll share it with your class representative.
Okay, sir.
Okay, thank you.
Thank
Thank
you.
you.